One of the question is this one. 1C, it has 5 times a tangent x plus b to the 4th power, and you have to differentiate this. Okay. Now this one is 1C. This one is interesting because a and b are considered as constants, and you're differentiating by x. Okay. Now, if having these a and b becomes so hard for you to manage, then just change it to some other ones that other numbers and see if you can do it. So, for example, if you put something like 7 here and 4 there, can you differentiate it? If you can do that, try that first, and then you can come back and see. It's just this, I mean, it's not any different than doing that. Okay, so you can just come back and see if you can do this one too. There's just this mental barrier against having these general a and b. That's what makes it look hard, but it's not any harder than having 4 and 7 or any other number in here. Okay. All right, so let's try to differentiate this. First, you have to identify the inside function. So this thing inside is like an x, right? So if I put an x here, so I can cover the entire thing, and this is like x. So you're really differentiating 5 times x to the 4th power. If you differentiate that, 5 is just a constant, so that comes out, and x to the 4th power differentiates. 4 comes down as 4. 4 times 4x to the 3rd. That's what you have, right? It's 4x to the 3rd. Well, what is this x really? The one that I'm covering is this entire thing. So that one, a tangent x plus b is what I'm covering. And that thing has to be pulled out and differentiated. So this one has to be pulled out and differentiated. What is this again? That thing I covered is a tangent x plus b. And this is where the mentally challenging part of having to deal with a and b occurs. But just stay cool. It's not that hard. Just 5 times 4 is 20, so I'm just going to write down 20. A tangent x plus b to the 3rd power. All right. First of all, you have 2 terms, so you have to differentiate term by term. So this has to be differentiated, and b has to be differentiated. What's the derivative of b? 0, because it's a constant. Any constants differentiate to 0. This is a constant multiple. What do you do with constant multiple? You pull it outside the derivative, right? So you don't use product rule. Please don't use product rule for constant multiples. I beg you. So you're only differentiating tangent of x. So a comes outside because it's a constant multiple. B goes away because you're differentiating a constant by itself. What's the derivative of tangent? Secant squared, right? And therefore, since this is a constant multiple, I'll put in front and write down 20a, a times tangent x plus b to the 3rd power times secant squared of x. Yes?
On the test, do we have to show that second step, or can we go right into deriving it?
Oh, you can skip this step. It doesn't matter. Once you get used to this, you can just go from here straight to here. It wouldn't be that hard.